Okay, so we are going to be finding the solution to the system of equations. This is the 5th day we've been working on this. So what can happen when we find the solution to a system of equations? There are 3 possibilities.
Only can turn into slope-intercept form.
They can cross in one place, which gives you one solution. They can be parallel, which is no solution. Or they could be the exact same line, which would be infinitely many solutions. There are 3 possibilities for what can happen when you find a solution to a system of equations. There are also 3 different ways that you can find that solution to the system of equations. So the first way that I taught you to find the system or the solution to a system of equations was to graph. So I'm going to show you just really quickly. You don't have to write this down. This is how you would solve this system by graphing. We would it's not working. Let me try one more time. Not working. Okay, we could, if we graph, put these in slope-intercept form. So that would give me y equals negative x plus 7. Right, if I subtracted x from both sides. And then here, if I added y to both sides, that would be 2x equals y plus 2. And then I would subtract by 2. And that would give me y equals 2x minus 2. So now both of those are in slope-intercept form. Then we could either put those in our graphing calculator, or if we graph them by hand, right, how could I graph this by hand? This has a y-intercept of 7, so I go up to 7. Here it is. And then I would use a slope, which is negative 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Here is the line to the yellow graph. And then the red one, y equals 2x minus 2. Okay, so now to graph the second one, I'm going to go on my y-axis to negative 2, plot a point. Then I'll use the slope, which tells me to rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. That line's going to be somewhere like this. So now what's the solution to my system of equations? It's the point where the 2 lines intersect. Okay, what is that point? Looks like it's at about 3, 4, 3. Okay, so this is how you do it by graphing. What are the advantages of solving systems by graphing? Visualization. You can see what's happening. It's very tangible to see. The lines are parallel. The lines are the same. The lines intersect. All right, it kind of makes sense with our answers. What's another advantage of graphing? If you like making lines and pretty graphs and you're a drawer, right, that could be an advantage. To me, that's probably the only 2. What are disadvantages of solving systems by graphing?
It's hard to be exact.
Yeah, you have to be very precise when you draw your lines. Like, look, where did my lines cross? Well, I don't know, because I'm sloppy. I don't draw it very well. Right? It can be great if you've got your graphing calculator, right, and it graphs it for you. Another disadvantage is they need to be in slope-intercept form before you can do anything, even on your graphing calculator. So you have to be able to manipulate the equation, get it in slope-intercept form. All right, so that's kind of solving that by graphing. Any questions there? So we've done it by graphing. We've done it by substitution. Now the third way I'm going to teach you to solve systems of equations is by elimination. So for substitution, what did you need before you can start substitution?
Variable by itself.
You need a variable by itself. For elimination, the coefficient of the x is 1 and 2. So for elimination to work, they need to be the same number, and they need to be opposite sign. Right? That's not the case here. What's the coefficient of the y's? 1 and -1. It's the same number, but they are opposite sign. That means I can eliminate my y's. So in order for elimination to work, we need the same number, but opposite sign. And that's what will make them eliminate. So here we're going to start you with an easy one. This one, the y's have the same number, but they're opposite signed. So we're going to go ahead and combine our equations because that will eliminate the y's right at the get-go. Y minus y is 0. It's gone. What is x and 2x? 3x. What's the sign in front of the numbers? Positive 1, positive 2. 1 plus 2 is 3.
It equals 9.
7 and 2 combine to be 9. So now I have an equation with a single variable. So solve it. Get x by itself.
X equals 3.
Divide by 3. That means x equals 3. Now that we know what x is, it's just like substitution. You have to pick one and plug it in and find the y value. So this would be 3 plus y equals 7. When I subtract by 3, that tells me y equals 4. So my ordered pair is the ordered pair 3, 4. That's the point where the two lines meet.
Like this one's the easiest one.
It's elimination.
Is the easiest one that is,
All right, let's look at A. Do I have a variable that has opposite coefficients? No, the x has opposite signs, but one is 2 and one is -1. So if I combine 2 minus 1, that doesn't make x go away. That would be 1x if I combine them. But what if I combine -4 and +4? Why? That goes to 0. That's what I want to happen. So here I can combine them and eliminate the y's. -4y plus 4y is 0. Now what is 2x minus x? 1x, or just x. It is not 2. What is 2 and 3 combined to be? 5. Same sign, add and keep the sign. Now, do I have a variable by itself? I already do. X is 5. So now if I know x is 5, I can take that information, plug it into one of my original two equations. This would be 2 times 5 minus 4y equals 2. That would give me 10 minus 4y equals 2. I could subtract by 10. That gives me -4y equals -8. And then if I divide by -4,
+2.
I get y equals +2. So the ordered pair where these meet is at 5, 2. Questions? Give you 60 seconds to try B. And I'm going to call on you, one of you at random, to work it.
Is this one harder?
No. Okay, if I combine these, do I have anything that'll eliminate right at the get-go?
Yes.
Yes.
X and negative
2x minus 2x. Those eliminate to give you 0. What is 3y and 2y?
5y.
That is 5y. 1 minus 6.
Negative 5.
Negative 5. Y is being multiplied by 5, which means you need to divide by 5.
Equals negative 1.
So y equals negative 1. I'm going to take this information and plug it in.
Top one.
I would pick the top one. 2x plus 3 times negative 1 equals 1. It'll be
2x minus 3 equals 1.
2x minus 3 equals 1.
And then plus 3 to both sides.
Add 3 to both sides.
2x equals 4. Wait, no. Yeah.
2x equals 4.
Then x equals 2.
So divide by 2. So x equals 2. So the ordered pair is x being 2, y being negative 1. That's where they meet. By elimination. So do I have any opposite variables? No. The x's are 1 and 2. The y's are 3 and 2. I don't have any that are opposite. So here's what you have to do using elimination. You can multiply one equation through everything by the same number, and you don't change the equation. You just change the numbers in front of it. So here's what I would do. I would look, do I have any variables that have a 1 in front of them? Yeah, this x. So that's the easiest one to manipulate. It's a 1 right now, and if I wanted to make it eliminate with a 2, I would want it to become a negative 2. So how can I make 1 become negative 2? I can multiply it by negative 2. So I'm going to multiply everything in the first equation by negative 2. So what is negative 2 times x?
Negative 2x.
Now those are going to eliminate. That's what I want to happen. What's negative 2 times 3y?
Negative 5.
Negative 6y.
6.
Negative 2 times 7? Negative 14. You have to multiply the entire equation through by that number. Now do I have any opposite variables?
Yes.
I do.
Every single one.
So combine them. Well, 2x minus 2x have the same number and are opposite. So they'll eliminate. That may be a better question. Do I have anything that will eliminate? The 2x minus 2x will eliminate. What is 2y minus 6y?
Wait,
Negative
2y.
4y.
Negative 4y. What is 6 minus 14?
Negative 8.
Again, if you don't know those in your head, put them in your calculator. No shame. You just got to get the answer. If you need help, put it in your calculator. Let me know. Is the y by itself?
No,
It's being multiplied by negative 4. So I divide by negative 4 on both sides. That tells me y is equal to positive 2. Now I know what...
Wait, would we use the manipulated equation or just use the
You can pick
original?
any of those three.
3, so, oh, okay.
You could pick the one in red or the 2 you started with. I would pick the very top one.
Yeah.
Because it has an x, it has a 1 in front of it. That's going to make it a little bit easier. So I would plug 2 in there. That's going to give me x plus 3 times 2 equals 7. 3 times 2 is 6 equals 7. And now subtract by 6. X equals 1. So the ordered pair would be 1, 2. Okay, so looking at A, what's going to be the easiest thing to eliminate? Nothing will eliminate right off the get-go, but what would be easiest?
The 2y and
Oh.
negative 5y. Well, it wouldn't eliminate, never mind. It'd be, do x, you'll have to manipulate the problem.
X will be the easiest. Remember, if I have a number, or if I have a variable with a 1 in front of it, that's the easiest to work with. So because this x has a 1 in front of it, I would try to eliminate the x's. Okay, so this is currently an x, and I want it to eliminate with 2x. So what do I need that number to become?
-2.
-2. So how can I make 1 become -2?
Multiply everything in the problem by -2.
Multiply everything by -2. Now, -2 times x is -2x. -2 times 2y, -4y. -2 times 4, -8. Now, do we have anything that will eliminate?
Yes, the -2.
2x minus 2x eliminates. -5y minus 4y is -9y.
Oh, what?
Make 'em
Same signs, add and keep the sign.
Why did I say 20? Oh, I was.
You multiplied them.
Yeah.
When I say combine, I mean add or subtract. But I never say add or subtract, I just say combine. Because you do what the signs tell you to do. If I combine -1 and -8,
You get -9.
-9. Same signs, add and keep the sign. Y is being multiplied by -9. I'm going to divide by -9. That's going to leave me with y equals 1. I now know what y is. I can take that, plug it into any of the equations I've worked with so far. I would pick the very top one. I'll plug 1 in for y. That's going to give me x plus 2 times 1, which is 2, equals 4. If I subtract by 2, that tells me x is 2. So the ordered pair where these two lines intersect is at 2, 1.
It's been a lot of 1, 2 like combination things.
They're giving you nice, easy numbers right now. Trying to bring you into it very kindly.
It's like one of those subscriptions. It's like, oh yeah, it's pretty
Yeah.
cheap at first, and then you
Look
get
how great
this
this is.
$75.99 each month.
Yeah. We'll give you the first month for 99 cents only.
Yeah, after that. It's
And then $24.99 a month. Okay. So if I look at B, do I have anything that will eliminate at the beginning?
No, you don't.
I don't. I have nothing that will eliminate right off the get-go. So now I need to decide what looks like it'd be easy to eliminate.
X.
What do you mean the bottom?
Oh,
We either have to pick the X's or the Y's.
Oh,
X.
the X.
Okay, the X's or the Y's. They both look good.
Yeah.
For me, I would pick Y's over X's. Why would I get rid of the Y? What is the benefit here?
Because already one's negative.
Because one's already negative. That's 100% why I would pick it. One is positive, one is negative. That makes my distribution a little bit easier because I don't have to multiply by a negative number. If you chose to get rid of the X's, that's fine. It's not wrong. Right? I just think mine is a little bit easier. So if I wanted to get rid of the Y's, how could I make this one that has a 1 in front of it cancel with a -2?
Multiply everything by 2.
Need to multiply everything here by 2. 2 times x is,
4x.
I'm sorry, 2 times 2x is 4x. 2 times y is 2y. 2 times 2 is 4. Now then the y's will cancel. That's what I was looking for, so let's combine everything else. X and 4x, 5x. -5 and 4,
-1.
-1. X is being multiplied by 5, so I need to divide by 5. That tells me x equals -1/5 or -0.2.
I just keep it a fraction.
That's fine. I would leave it as a fraction for me. I'm not scared of no fractions. If you're scared of fractions, put it as a decimal. This decimal's fine. -0.2 is fine.
Good decimal.
Huh?
This is a good decimal.
Yeah, it's a good decimal. It's not repeating. It's only 1 digit long. Who's a good fraction? Okay. Now, if I know x is -1/5, I'm going to take this information. I'm going to plug it in. to any of mine that I started with, I would pick the top one. Because the y already has a 1 in front of it. So that makes it a little bit easier. All right, so this would give me 2 times x, which is negative 1/5, plus y equals 2. 2 times negative 1/5 is negative 2/5, plus y equals 2. And now y is not by itself because it's being subtracted by 2/5, which means I need to add by 2/5. That would give me y equals 2 plus 2/5. We don't use mixed numbers in algebra. It is 2 and 2/5. Make it improper. 12/5. The y value here would be 12/5. What you could do, you could turn the red 2 here into a fraction. So as a fraction, that is 2/1. And then to get a denominator of 5, I need to multiply by 5 on top and bottom. So that would be 10/5. And so 10/5 plus 2/5 is 12/5. Or again, put it in your calculator, right?
Why did you choose that problem instead of the other one?
Why did I choose what?
Why did you choose the top problem instead of the bottom problem, where x is already...
Okay, because that would have been fine. I would have moved the x over. So I'd had to do -5 minus or plus 1/5.
Yeah.
And then I had to divide that by -2.
Oh, I got it. It'd just be...
I don't want to divide. I mean, it's about the same number of steps.
Yeah.
But I would rather take care of the multiplying early instead of having a fraction then dividing that fraction by a number. I don't want to get into that.
It became bad.
But again, it's not wrong if you pick it. Just maybe a step harder.
I got you.
So the point where these lines meet is at -1/5 and 12/5. That would have been very hard to find graphing by hand. Now graphing on your calculator, maybe not so bad. Yeah, this is a hard one. So we're going to solve this system of equations by using elimination. Do I have anything that eliminates at the beginning?
Nope.
No. Do I have any coefficients of 1?
Nope.
No. Okay. So I have nothing good to go on. So I just need to pick one that I want to eliminate. So for me, what's something that looks like it would be good to eliminate?
The bottom.
Well, you can't eliminate the bottom. You have to either choose the x's or the y's.
I don't know.
I would pick the y's. The only thing I see that's even close to eliminating is
negative and a positive.
one's negative, one's positive. So I would try to eliminate the y's. That has one thing that's got going for it. One's positive, one's negative. Sorry I'm boring you. I am so sorry. Okay. So if I want to eliminate those y's, one is -3, one is +2. Can I multiply one of those numbers by something to give me the other number?
No.
Not easily.
You'd have to do both, though. You have to do both of the equations.
We could multiply both of them
Like
by
a common denominator kind of thing.
the least common multiple.
Yeah.
If you remember doing,
What?
If you multiply the top and the bottom, you have to have the same number?
no,
You know, okay, I didn't know that.
no, I can multiply the top and the bottom by different things and still make it eliminate. So what's the least common multiple of -3 and 2? It is 6. They can both become a 6. So I'm going to multiply them both to make the y's become a 6. One positive, one negative. So they will eliminate.
Slow down.
I haven't even done anything yet. I just talked.
I don't know. Okay,
Slow down.
Just go. Just go.
Do you have a question?
No, not yet. I will in a minute.
So if I want to make the top one, because it's already negative, let's make the y become -6. So what do I need to multiply -3 by to make it become -6? +2. So I'm going to multiply everything in the first equation by 2. That would give me 8x minus 6y equals -18. Now, I've made the y value -6. So in the second equation, I want it to become positive 6y. So that way they'll cancel. So what can I multiply 2 by to make it become 6y? 3. 3 times 3x is 9x. 3 times 2y is positive 6y. 3 times -11 is -33. Now that I've done that, do I have something that will cancel? All right, now it's just like the other ones. All right, that's as hard as it can get. Right there. 9x and 8x combine to give me 17x. -33 minus 18 combines to be -51.
I thought -2 makes it positive.
When you're multiplying, when you're adding and subtracting, same sign, add and keep the sign. Again, if you get a little confused, put it in your calculator just to double check. Okay, x is being multiplied by 17, which means I need to divide by 17. X is -3.
Now, we gotta put that into another equation.
Take that and plug it in. There's no good one to plug it into. I can pick any of the 4. None of them that are great. I would pick the bottom one. Here's the only reason I'd pick the bottom one. Because the coefficients in front of my x's and y are both positive. That's the only thing it's got going for it. I don't have to deal with a negative.
I would've went with the fourth equation because it's all a multiple of 3 and it'd be easier to all go by. So.
That's fine. There's nothing wrong. There's not a great one here.
Yeah, you gotta.
So I would have 3 times -3 plus 2 times y equals -11. 3 times -3 is -9. Plus 2y equals -11. Now I need to add by 9 to get rid of this -9. That's going to give me 2y equals -2. Divide by 2, which means y equals -1. So I would get the ordered pair, -3, -1 is the point where those two lines intersect.
My paper's on that.
Last one I'm showing you today.
Wow, I just got a whole new page.
Or you mean keep going? I'll keep going then. Okay, so I've got x minus 3y equals -4. 2x minus 6y equals 6. Do I have anything here that will eliminate right now? No. Do I have anything that is good to help me get elimination going?
I'd say the X.
The x's, I agree. Because that top x can become, what do I need that top x? It has a coefficient of 1.
-2.
I need it to become -2. So what would I multiply by to make this -2? -2. -2 times x is -2x. -2 times 3y is positive 6y. -2 times -4 is positive 8. Now my x's are going to eliminate. That's what I want to happen. So 2x minus 2x eliminates. -6y plus 6y eliminates. And so what's left on the left side?
6 and 8.
On the left side, nothing.
Nothing. So
On the right side, 6 and 8 combine to be 14. So anytime your x's and y's both eliminate themselves, you're going to be left with a math statement. What is the math statement they left me with? 0 equals 14. Is that a true math statement? Does 0 equal 14? It does not. That means there are no solution. That means graphically, if I were to graph the two lines, they are parallel, never touching. So they never intersect. That's why it's no solution. What happens if your variables eliminate and you're left with a true math statement?
then it is a solution.
Then it's infinitely many solutions. Let's see if I can find one of those.